This is Dr. Holt. In this video I want to discuss how to add vectors graphically using only components, and then I want to talk about how I can actually find what the resulting angle would be and what the overall magnitude would be. In this problem I have three vectors. I have vector A, tail is located here, the head is located here. I have vector B located with tail here, head located here, and C, tail here and head located here. Now with B, I'm going to make it look a little bit better. I wanted this to be right on the grid, so it's just a little bit off, but okay, it's pretty close. I'm going to make it shorten just a little bit for you. Okay. All right, that's a little bit better. All right. Now here I'm going to do minus 2a plus b minus 1/3 c. Okay, I'm going to move the vectors. Now you don't have to, but I'm going to move the vectors. I'm going to move them all down to the intersection at the x and y axis. I'll move A right here over, so I know that's A. I will move B over here, like this, and slide this over here. I will move C over here. Again, you don't have to do that. Okay, now let's start with A, and before we do the multiplication, I'm just going to find out what the components would be of just A. Okay, now A is going in this direction, so I'm going to draw the components. I'll have one component, an x component going this way here, all the way over to here, and a y component going up like this. Okay, now let me orient that just a little bit down so it's right on in there. Right. And again, I will color that red so you know that is a component. And color that red here too so you know it's a component. All right. So I'm going to define what the x component of A would be. So I'm going to write it like this. The A vector how far do I go to the right? 1, 2, 3, 4, 5. So I'll put a 5 in here, comma. And we'll pretend these vectors are, we'll say it's newtons, okay? And each square I go represents 1 newton. So I got 5 newtons this way. And actually I'll go ahead and put the units on it here while I'm at it. So I got 5 newtons here, comma. How far do I go up in y? 1, 2, 3, 4, 5, 6. I'll put 6 newtons this way. All right, now if you notice, this is, again, when you add vectors, you start out tail, tail. I have head, tail, end up head, head. So these are my components of A. I come over to B. With the B vector, I will draw the components. The head is the tail is here, head is here. So the x component is going to go this way. And the y component is going to go down like this. Again, adding vectors, tail, tail, head, head. I will color coordinate those with the color of the vector. Okay. So I did not color. I'll try to grab it, but make it colored now. All right. So I'm going to label what B is. The B vector is going to have, and how far do I go? I go 1, 2, 3, 4, 5. But I'm going in the negative direction, so I'll make that -5. And again, we said the units here is newtons, so I go -5 newtons. How far do I go down? In the vertical, 1, 2. I will make that -2 newtons. And I want to do that. Let me make that right. So those are the components. All right, now we're ready to go to C. I come to the C, I will draw the components. I will have a y value going down this direction, and then an x direction going this way here. Again, I'll try to color coordinate those. here, I'll do this in blue. So the C vector, how far did I go in the X? 1, 2 newtons. Comma, how far did I go down the Y? I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going down, so I do negative 10 newtons. Okay, again, I haven't done any multiplication. Now I'm going to go ahead and do the minus 2a. Could I not say that the minus 2a vector is going to equal to, I'm going to multiply everything here by negative 2. It's going to equal to negative 10 newtons, comma, negative 12 newtons. What is B? Well, B is not going to change, right? B vector is exactly what we got, minus 5 newtons, minus 2 newtons. What is minus 1/3 C? So I'm going to multiply these all by negative 1/3 when I get minus 2 over 3 newtons. And then negative 10/3. I'm sorry, by negative 10/3 newtons positive. Okay, now my resultant vector. To find my resultant vector, all I have to do is go down this column here. I got negative 10 plus negative 5. That's going to give me negative 15. Negative 15 and 2/3. Now we can convert that value of negative 43 thirds. That's going to give me negative 43 over 3 newtons. Okay, I come down this column, I got negative 12 plus negative 2, that's negative 14, plus 10 thirds, add that together, and that's going to give me a value of negative 32 over 3 newtons. So those are the components of my resulting vector by doing negative 2a plus b minus 1/3 c. Now if I want to find the magnitude and the actual location, or excuse me, the magnitude and the actual angle, I'll show you how to do that. I'm going to go ahead and just create a little spot here. I'm going to get rid of these grids and color this white so you can kind of see what's going on, so you can see everything. I'll grab this. I will make that properties, and I will make it solid, and I'll make it white. Alright, I'm going to do a rough sketch of this vector. I'm not going to draw it to scale. But my components, I'm going to pick a point. I'm going to go minus 43 thirds this way. I'm going to go down 32 thirds this way. The magnitude of that vector, or the direction of that vector is going to go down this way here. So again, this distance here represents 43 over 3. I'm not going to negate it because the arrow shows it going negative. This vector represents 32 over 3. Again, I'm not going to show the negative because the arrowhead is pointing down. At this point, we can go right to Pythagorean Theorem. Now you're dealing with Pythagorean Theorem. If you have a negative, like a negative 43 over 3, make sure you put that in parentheses. So 43 divided by 3, I'm going to square that, plus in parentheses 32 divided by 3. I'm dropping negatives, what I'm doing. Square that. I'm going to take the square root of that. Second square root. Put my value in, and that's going to give me the magnitude of r. R right here, the r vector. The magnitude of r is going to represent 17.87 newtons. Now if I want this angle here, what do I know about that angle? I know the opposite and I know the adjacent, so I go to my tangent. So I can take 32 divided by 3 and then divide, in parentheses, 43 divided by 3. Now I'm going to go to my second tan, or my inverse tan. and I'm going to get an angle right there. This angle here would be 36.66 degrees. Sorry, make that better. 36.66. Change it. So that's 36.66 coming off the horizontal. All right. So my direction of my resultant would be going down in this direction here. It would have a negative x component and a negative y component. It would have a magnitude of 17.87 newtons, and it would have an angle of 36.66 degrees. All right, I hope this video was useful. Again, follow this approach that I've done here before you do any of the multiplication, and you should do just fine when you do that. And then all you have to do is add together all the column of the x's, add all the columns of the y. You can show your resultant in component form like this, or if you're asked for the actual magnitude, then you're going to be forced to go to Pythagorean Theorem. If you want your angle, I recommend you make a sketch based upon this, and then using the inverse tangent, you can find the angle. I wish you guys the best of luck as you work these type of problems.